Okay. All right. So I'm still milling. So for people who had been watching this video, we now have sound, and to explain, this is a video to give you an idea of how to create some microcrystals in a given grain. So you might have seen a lot of going back and forth so far because I could not understand why the fib, which is the ion beam on that side, was giving me such bad results as I was carving, and I realized it's because I was at a very low current. So this is the rule number one. Normally, you always check your current, and I forgot to do so. But here we are at 30 kV, which is the operating, sorry, not current voltage. This is the operating voltage we want to be at. The different currents we're going to choose as a function of what we're trying to do. Now, as you can see earlier, if you're watching the video earlier, you might have seen that I was trying to create this bullseye pattern, and the result was not very, it's very, very faint, not very visible. Now we have a much starker, much nicer contrast, and you can see that we have some sharp lines that are being drawn, which is very good for our purposes. You might have seen as well that I was trying to do a little square here on the side. That is because I have never done any fibbing on this particular grain before. So usually I like to do a little square of a depth of 2 or 3 microns, and then I look at what actual depth I end up measuring. And that gives me what I call the milling ratio. The milling ratio is, as the name indicates, the ratio between the actual milling depth versus the one that's been programmed in the fib. So here, the square I did it at low voltage, so it's not a very good reading. So I'm gonna redo it after I'm done with the bullseye, and that's gonna give me a good reading as to what that milling ratio is. It can be anywhere from 0.3 to 3 generally. That's what I've seen. Now, as to why I'm doing the bullseye pattern, I will use that pattern as a way to, I will use it for calibrating purposes. So every time we'll change current and I need to potentially do some beam shifts, I need to, sort of adjust the focus, I will do it on the bullseye pattern. Why? Because when using the fib, you can sometimes use very high currents. And if you're doing your focusing, you're calibrating directly on your work area where you're trying to make your microcrystals, you might damage them. The bullseye is sacrificial. It's here to take a beating because of the high current. So we don't worry particularly about it. And now I'm actually going to stop this fib milling because it's visible enough. I don't need more than this. This is perfectly fine, and I can use it for future purposes. So I'm going to stop it there. There you go. And now, compared to earlier, we have something that's much, much, much starker in the shape. You can see you have sort of beautifully shaped circles and lines. Now, this is still at a pretty high current, 6.4 nano. Sorry, no, that's not 6.4. It's here. It's 3 nanoamp, which is pretty high. It's one of the highest we're going to use. So we don't expect a crazy amount of detail here, but we actually already get something that's pretty good. Now, I'm going to do the same thing with this tiny square that I was explaining earlier. You might also have seen me trace some boundaries, and those are the boundaries that correspond roughly to where the grain is. There's been EBSDs in the past to figure out where that grain is. All right, so I'm going to create another of those little rectangles. They're just here again to test the milling ratio. So I'm going to come here very quickly, of course, because we are at high current. We want to avoid looking at the space for too long. Just going to adjust the focus a teeny bit. Okay, we're pretty good. And I'm just going to create a 5 by 5 square. I found that it's enough. And I'll put it as 2 microns in depth. So at 3 nanoamps, that's going to be milled in just a minute. Remember that when you use the I-beam, you can always use the I-spy function here, but you also need to undo the pulsing on the E-beam, sorry. So otherwise you won't see anything. So here I've set up that the I-spy refreshes the E-beam window every 6 seconds, and you can see essentially the thing happening live. Now we can see that this is much sharper in shape than the one we had above, which was done at a lower voltage. Otherwise, at the beginning of the video, you might have seen me try to find the eccentric height. That also took some time, again, because the voltage was low, so I sort of lost a fair amount of time here, unfortunately. But now that we've got the right voltage on both sides, we're ready to roll. We've got our eccentric height. This particular fib, compared to the one I usually use, tends to have more beam shifts happening at different voltages, at different currents. So that's something to take into account, and it can be an issue. All right, so now we have a very, very clear depth at which we've gone, and we can measure that very easily. And that depth is going to go from here to here. And we are in cross section, right? Because we are cutting through the matter. So here, in order to get a good read of the value, we are in cross section, and we see 3.33. So that gives us a milling ratio of dividing this by 2 of about 1.666. So 1 2/3 to 1. That's our milling ratio. This is great news because that means that our orientation actually allows us to mill faster than what the fib tells us. So we're gonna keep that in mind, and from there we can sort of modify all the length, all the depth based on this milling ratio. Okay, so now that we've done the bullseye, that we've done the square. Sorry, I want to delete this. I'm going to go back to the E-beam, and you can see here I was pretty high magnification, 15K, with a high current on the I-beam. So I just looked at it for a second and already sort of damaged the surface a bit. So this is why this pattern is going to come in handy, because we're going to be able to sort of use this as a way to, we can destroy it just in order to get our focus. Okay, I'm just going to check my usual recipes to create those microcrystals, and I'll be right back. Okay, so we know this entire grain is oriented in a direction we want. So I'm going to start creating some microcrystals about here, just above the bullseye pattern. And we're going to start with a very high current. I think we're going to start with about 15 nanoamp because we want to, get enough of them done. Now, 15 nanoamps is particular because it's one of those high current where the SIOS has very cleverly put there's a guard that prevents the E-beam from actually seeing anything as the I-beam is on. But that also means that every time you switch between the E-beam and the I-beam, you prevent the E-beam from seeing anything. Every time you switch between the two, it takes a couple seconds. So keep that in mind. So here, we're going to be able to start creating our patterns. So we take this patterning control, and we're going to create a pattern here. Can zoom in a bit more, maybe. I'm going to move slightly. There you go. Because I'm going to try to create 4 today. 4 is a good number. Usually it's enough for our purposes. Now, for these, I usually create them 30 microns in outer diameter and simply 5 microns in inner diameter. That's usually plenty enough. Yeah, that's usually plenty enough. You can get away with making a 25 micron pattern in the outer diameter. I like 30 because it just sometimes I happen to make experiments with different temperatures, and because of the thermal drift, I really want to make sure that I don't start hitting the sides. Okay, so this guy, and because normally we want this to be at about a, we want this to be roughly at a depth of about 5 microns. But again, we've established our milling ratio is a bit better than that. So if we put it at about 3.5 microns, we should already have the right, we should land at a final depth of actually 5 microns. So let's just double check the math real quick. Yeah, three microns is going to be plenty enough. It's actually it's exactly the same ratio. So here we wanted 3 microns deep, 5 microns in the middle that are untouched, and 30 microns on the side. And here's a little trick to make it go a bit faster. If we want 4, we have a pattern. We can ask it to build a pattern array, and it gives you this pitch and dimension. Mine are all going to be in the X direction, and I want to create 4. And I want them to be separated by 35, because that way, if I put them at 30, they will be right next to one another. I'd like a couple microns in between them so I can differentiate them enough. And in Y, I'm simply going to have the one I have currently, so it doesn't matter. So I put it as 4X, 1Y, and 35 microns in pitch, and we will get this. That's exactly what we want. This is lovely. Okay, I'm going to place them here. I am confident that I am in the area of the grain where I have the same orientation everywhere. And this is going to work for us. Now, as you can see, altogether, that gives us about a 32 minutes running time. That's not too bad at all. So I'm going to launch it, and we're going to see. I'm going to launch it. I'm going to continue to focus on it on the E-beam. And here, a small thing. You can either place them in parallel or make them in serial. So serial means they're gonna the I-beam is gonna mill each pattern separately. Parallel is gonna make them all at the same time. I like to use serial because if there is an issue with the orientation, with the calibration, with the eccentric height, if there's any sort of issue, we will see it in the first pattern, and we can just stop the experiment in there, and we haven't ruined our other patterns at all. But if you do it as parallel, you might run into an issue where like maybe there's a focus issue, and unfortunately at this point you've already started making all 4 of them. So I will go for serial. It doesn't change anything. The time stays the same. Go for serial, and I'll keep my iSpy on. Okay, so as you can see, we only started on the pattern number 1 for now, and I'm revealing it here. It has started milling. Currently looks good. I will keep an eye on it, but in the meantime, I'll just mute myself because there's not going to be anything else happening for a while. All right, and we're back. We have now finished our first stage of fibbing, and as you can see, we have a very good result. The lines are very sharp. It looks very good. I'm gonna have a quick look by zooming in. Now, at this point, the microcrystals look a bit like the sandcastle you do with a bucket on the beach. That's usually a good sign. This shape is a good sign. However, I can already tell that despite what we were told here with the milling ratio, we probably haven't reached 5 microns in depth. I think we're a bit below that. Yeah, we're closer to 4.3 and all that. So it could be we could use a bit more depth there. So what we're gonna do is as you can see, I have not deleted the fib pattern yet, the patterning fibs there. So what we're gonna do is simply relaunch them real quick and just give it like a couple more minutes. So in order to do that, I've moved a bit, but that's okay. I can just place them back over there. Of course, you have to be a bit precise. At this point, if we're not exactly center, that's not a big issue because those, again, those sort of sandcastle shapes in the middle are going to be thinned out because at the end, the microcrystals are just going to be about 2 microns in diameter. So I'm just going to add for maybe 0.5 microns. Okay, let's say 0.8. I'd like to have maybe a bit more. Let me think. Actually, I think 0.5 should be enough. As you can see, the total time here is only 5 minutes extra. Here, again, we can do it serial parallel, doesn't change much. And don't be alarmed that, we sort of stop halfway and we starting again. That's not going to have a massive impact on anything. So I'm going to start again for 5 more minutes. And again, I place the I spy so I can keep track on things. And we might see a slight wobble because at the place where it starts milling again, but that's completely fine. All right, I'll see you in 5 minutes. Okay, so now we've added a bit of depth to this first pattern, and from having done that a couple times, I can already tell that we have a bit, I think now we have about the right depth, but of course we're going to check. And we want something close to 5. And yeah, we have, says, yeah, even 5.3. Okay, so we're perfectly fine here. I'd rather have a bit more than a bit less on average. Okay, so I'm also going to check on the latest, on the furthest out, because of course, as try as you may, you're never going to get perfect alignment, and so you can sometimes get slight difference in the final thing. And you can see here we're closer to like 5.1, 5.2 maybe. So it's slightly less deep, but again, it's like the alignment of the machine is as good as you can make it, but it's never going to be perfect. But it's certainly good enough for our purposes. So at this point, we can remove this big pattern that we have here. Okay, I'm just going to delete all of it. There you go. And for our second stage, we're going to go to a lower, oops, excuse me, I did not mean to do that. Okay, sorry, I wanted to go here. We're going to use our good old focusing target. So I'm going to keep it here. And for the second stage, we want to go to lower current, so we have better quality. Let me check again my notes. Okay, and here we're going to drop down to, I think 1 nanoamp should be enough. So we essentially going down 1 order of magnitude in terms of current. So now when we open the I-beam, we don't get the shield anymore. So as you can see, what I do is every time I take the I-beam, I unpause it and pause it straight away. Because then you can use the auto contrast brightness, and it's actually going to stay as paused, and it will only start when you want it to. And you can see we actually have something that's pretty good. We could slightly shift compared to the E-beam. There you go. We really want it in the center, just like we have it here, but we're really close. And in terms of focus, again, you can go quite close. So as you get close here, that thing, and you can play a bit with the focus to get the best result. And yeah, this is about as good as we're going to get it. And again, sufficient for our purposes. Playing with a stigmata a bit, but usually there's not much stigmation issues. As you can see, if I back out, you can see that I already have a faint imprint. It's not a really big deal, but if I'm trying to make more samples later, more microcrystals later, I will again will have to focus the 15 nanoamp, and the 15 nanoamp, as you can imagine, is going to damage that target quite a lot. But we're good with our 1 nanoamp, and now the big difference is that we're going to work pillar per pillar, so one microcrystal at a time. So I'm going to grab this bad boy over here, which will look like a circle from up there. And then from there, the idea is simply that we want to thin it by essentially grabbing it entirely. So this mills very cleanly. I'm really pleased with it, because sometimes the milling doesn't give you a very precise amount where you walk in. And so the difference that we see here, the difference between the dark circle in the middle and the ring around, is that the dark circle at the center, the dark disk, is actually the top of the pillar, and the light ring that we see around it, that's actually the sides. And we want the sides to be as pretty much almost as vertical as possible. We'll always have a bit of taper, but it's okay. So here you can see the outer diameter is about 5.8. That's completely fine. And inner diameter, we're going to bring it down to about 3. I think 3 microns should be enough. Our final size that we want at the end is about 2.2 microns, 2 microns usually. So here we'll put it at 3, and then we're going to have another stage where we again make it a bit smaller. Of course, we want to go across the entire length, which is about 5 microns. So uh, it's about 5 microns, but because we working on relatively small scale, we have to take into account that when we do this, when we use the fib at these lengths, at these relatively small quantities, especially the small surface area, the impact of the fib is going to be stronger than expected. So we actually probably don't need. So first of all, from the 5 microns, we know that we would only need 3 microns due to the milling ratio. But because the fib is going to be concentrated on a small surface area, I think we can probably get away with 2. So I'm going to start with 2, which is about 2-minute pattern. As always, I'm going to keep an eye on the I-SPY, but I wouldn't be surprised that after 2 microns, we've already reached the bottom or even a bit further. All right, and let's get started. We're all good. 1 nanometer, yeah, we're all good. Okay, I'm turning on the I-SPY. Currently looks perfectly fine. And we can already see, we can already see it's being, of course, made much smaller. It's always a bit scary at first because we think that it's just simply going to completely disappear, but you can see that it's actually shaping more and more, and it's actually milling very nicely right now. Don't be alarmed that the quality on the E-beam is not that great. I haven't redone the focus, so that's sort of my bad, but it's also only capturing a very short picture. Normally, when you see good quality E-beam, is because we're integrating the picture. This is this option over here. Now you can see that there's also a sort of mini crater that's also being formed at the bottom. That is completely fine. Do not worry, it's sort of expected. This will generally be about a micron deep, and that's perfect because we actually want our final column to be 6 microns in total length. Now see, it's a bit of a stubby boy. It's a bit stubby, but that's what we want. It's looking really good, and you can see again, depending on the material that you're going to use, it will not fib always in the same way. Here it's milling very nicely from top to bottom, and we get this gradual removal of the matter from the top to the bottom. Sometimes you'll get something that's going to be shards. Sometimes you'll see shards that are sort of going to disappear, sort of melt. It looks more like ice crystals melting. So it's very different. Now, I'm keeping an eye on this one because this is the first one, and I essentially want to stop it when I don't see much of a taper here anymore, and that's going to be probably in a few seconds. So it seems like 2 micron is already a bit too much. Well, too much. It's a way of speaking, but it's already a bit more than what we need. I think we can probably get away with 1.7 microns or so. Yeah, this is looking good. I think I'm going to stop it about here, up, and I'm going to change a bit. There you go. Actually, we can see it a bit better. Improve on the focus. There you go. And you can see that it's gotten a bit deep. So I'm going to stop it there for now. And I think this is good. So that tells us that for the others, I'm going to do the same one. Should jump on the next one here. But this guy is probably only going to need, I'll put it as 1.6 maybe. So here, of course, I start the I-beam very briefly just to realign, because now we're looking at a different guy. Same size, inner diameter, 3 microns. Z size, let's put 1.6. And that should about correspond to what we want. I put the I-SPY, and I'll see you in a couple of minutes. Okay, we're back, and this one is looking good as well. We still have this taper at the bottom, but that's completely fine. I like to sometimes also look at them in the afterwards. Yeah, this is about what I would expect in terms of ring size. So it seems that we're doing well. For the next two, I'm not going to particular comment on them. I'm just going to do the same thing. But what's important on these ones is that while we did the first step as just all four patterns at once, of course, here at this point, you can understand that um, we actually want to center our milling patterns around the already existing sort of stub. And of course, those patterns, those stubs that are created, those proto columns are not going to be exactly aligned between every sample. So you really want to take them one by one and do each carvings, each milling separately, because otherwise you might simply, if you want to do them all at once, I think you're going to have alignment issues. All right, number 3. And we are back. All right, this was our final one, correct? Oh no, sorry, there's one more. Sorry, this was number 3. Just gonna do number 4 real quick. Well, those are actually very well aligned. It not all, so all grains and all materials are going to mill slightly differently, and part of experience is just sort of being able to read that and modify your patterns and such as it goes, such as the depth that I was talking about earlier. But this one, as far as materials go, this one mills very nicely. It's very clean lines, no shards, no problems like that. All right, number 4. Okay, and now this is the fourth one done. So let's go back to the first. There's no particular reason I go back from left to right. It's just force of habit. I like to, it's easier for me to keep track. I'm going to go back to this guy, and this is where we get to the final thinning phase. So this is where we're going to go to the final shape that we actually want, the final diameter. And it's usually is the step that takes a bit longer because you sometimes, sometimes you get it bang on from the first time. Sometimes it takes a bit more time. So here we're going to do as before. We want a circle that's just big enough to envelop the diameter of the pillar. So let's try 3.5. You can see 3.5 is maybe a bit short. Let's call it maybe 4. Okay, 4 maybe a bit big. Doesn't necessarily need to be that big. Okay, 3.8 it is. 3.8, you see, I just about encompass the diameter of the pillar from top to bottom. And in the diameter, we're going to set it as 2. And here we're going to set it up as 2.2. So 2.2 is essentially kind of the final size that we want. Now, one thing that I like is also being able to, you see this dark circle again, this is the flat top of the crystal. And we of course want a final result to sort of fit there. We don't want something like this because then we're going to have an issue with the top being sort of lopsided. So we want to stay in that dark circle, which usually, yes, ends up being already 2.2 microns roughly. Here, I'm going to add maybe a teeny bit on the outer diameter to make sure that I capture the entire thing. There you go. In terms of Z size, we're going to start with probably 0.5. Oh, but before that, sorry, I completely forgot. My bad. We need to go down in current because we're going to go to some at this point, we're going to be some very precise stuff. So I go back to my target, although at this point, we're going to go down to essentially in the sort of 100 PA. So 0.1 nanoamp or 50 PA range. So this is very low current. At this point, you are not going to damage your sample. If it's a metal or ceramic, you should be fine. But we can get some really good focus, maybe slightly better. Okay, this is pretty good. So here at this point, I'm not too worried about leaving the I-beam on because again, we're talking very low current. You can see that it's barely left a trace on the focusing target. So it's not going to be damaging a sample here, but it's still a good habit to use the I-beam, have the I-beam on as little as possible, as little as necessary. Okay, I'm just gonna go here. What's very good too is that if you place your beam shift properly, when you have a good view of the top with the I-beam, you get a good view of your pillar with the E-beam. So here you can see that we get a bit of fuzziness on the outside. That's completely fine. That's because towards the bottom, it is actually quite fuzzy. So you want to sort of focus on the central aspect here. And I think that maybe I've played a bit too much with a stigmata and I've added, there you go. There we go. That's pretty good. All right, so sorry, I take my pattern from earlier that I was, you can see that now we've gotten to lower current. We can see that the diameter of the pillar, we definitely needed that 4 micron of outer diameter. And we're going to start with 1 micron. That should not, actually, let's start with 0.5. Again, this one tends to mill very nicely. So I'm going to start with 0.5, but you can see that at this low current, it already takes 2.5 minutes. Okay, so I'm having my I spy. So at the end, the result we'll obtain is, a column with a top diameter that's probably going to be slightly under 2 micron and a lower diameter that's probably going to be slightly over. I'd say generally you get something maybe 1.8, 1.9 at the top, and maybe 2.1, 2.2 at the bottom. As much as possible, like I said, our goal is to try and establish a really nice vertical line. We don't want that taper, and you can see it's like it's kind of shedding off on the side. It's already looking much better if you kind of follow how it's going to continue this way. And I'll show you at the end how I sort of measure that. And the last stage with any of those is always to measure everything and make sure that we have a limited amount of taper. We're trying to aim for a final taper on the microcrystal less than 1.5 degrees. I would say now that I've done it quite a few times, I'm generally able to get mine less than 1 degree in taper. All right, I'll let it run for a bit while keeping an eye on it, and I'll see you in a bit. Okay, we're back, and as you can see, we need to sort of do that one more time. We're not quite deep enough, so that's completely okay. We have the same pattern, and really, I can literally just, I would still double check, here. So this is important. I double checked the pattern because there's always some slight amount of drift, and that's to be expected. Uh, Over the course of the thing, it's not enough to be a massive issue, but as you can see, we had moved a few nanometers. So I'm just replacing it. I've got the same setup, and I'm going to continue. Okay, now that looks much better, as you can see, and we have a very nice column over here. I'm gonna just increase the mag here a bit. We have a very nice pillar. Now, there's still a bit of tape, a bit too much taper to my taste, and you could say like, oh, this looks fine. It's not bad, but we can do better. So I'm gonna, and there's no particular secret. I'm just gonna sort of give it another go over there. And in case it's not obvious, you've seen that um I had placed the pattern originally at 4 microns on the outside and 2.2 microns on the inside. And you can see that after placing that pattern all over, we actually still have about 3 microns in diameter. You can see that here the outer diameter of my pattern is 2.9 microns up there 3. So even though you write 4 microns to 2.2, it's not going to erase absolutely all of that, not at all. Remember to put the center. So here we have something more like this. Again, the top is a bit so now the top is a bit less than 2.2 microns. It's probably closer to 2. That is fine. That's what we want. It's completely expected. And you can see we have that. I'm going to put half a micron here because, again, as we get to smaller and smaller surface areas, the effect of the fib gets more and more concentrated. And I'm going to have a look at how it looks like. All right, and we're going to launch it now. We still have the iSpy active. And it's going to take a bit less than a minute. Well, one thing I like to do is, at this point, it can become a bit hard to really see the difference. So what I like to do is sort of place my mouse where my taper currently is, whoops, and see how it evolves in the iSpy. So I'm not going to touch it. I'm just going to wait, and you'll see that in 30 seconds, some matter will have disappeared and we're further away from the mouse. Okay, so you can see that we have removed a bit by where the mouse is, and here I'm going to have a quick look. Okay, and this is looking pretty good, but we have again lost some aspect. Now, usually I consider that we sort of close enough towards the end that if I do a 2.4, 2.2 around the pillar, that essentially the 2.4 mostly encompasses what we have here. That doesn't seem to be the case there. Let me have a bit of a look at the current values. So careful, earlier we were with cross-section. We do not want that cross-section anymore. So you go in this menu over here and you remove the cross-section. You just set it as correction none. So here we have about 2.15 at the top and about 2.53 at the bottom. So we're still a bit too big, but we're getting there. So I'm going to remove these. And I'm going to set this one as 2.8 maybe. Right, 2.8 should be good. 2.2 on the outside, that's still fine. And we'll keep it like this. Again, I placed my mouse. Well, now it's a cursor, but I want to see the difference. Okay, again, we have something slightly, we've removed a bit. It doesn't look like much, but it definitely adds up, especially because once we have a look here, you can see that we have removed a bit more. So at this point, there's not really a secret. You just kind of create smaller and smaller circles. Here, 2.6, so we're really getting close to the value that we want. If the final crystal ends up being 2.1 micron across the board, that's completely fine. We plus or minus 100 nanometers is not going to be an issue, but we still want to make sure that we have something that's very sharp and sort of vertical. Okay, what do we have here? Okay, we're getting closer and closer. So this is all good. At this point, what happens if I do 2.4? 2.4, we're still slightly tight, so I'll keep it at 2.6. And I'm actually gonna increase the Z size. That's just the equivalent of doing it twice for our purposes. At these very small scales, the depth, thinking in terms of depth doesn't make a lot of sense anymore, because you're really looking at like a very small ring surface area. And at this point, even material that tends to mill from top to bottom like this one is just going to look more like a general thinning of the entire piece at once. As you can see, earlier when we had a larger size and we're removing that matter at the top, it was really coming from the top to the bottom, but now that's not the case anymore. Okay, let's have a look here. Okay, it's definitely thinned out a bit, and I think now we have this 2.4, 2.2 situation. Yeah, now it's contained in 2.4, so that means we're about there. We're about done. You will see there is a slight taper at the top. Sometimes it happens naturally, sometimes it doesn't. It's actually pretty nice because we kind of want that to make sure that when we then compress these guys, that the stress state is like nicely spread across the entirety of the space. So here I'm gonna already have a look for the taper, and the thing I'm gonna do. So here actually I'm gonna place it in cross section. It doesn't matter. These guys are not going to be any different in cross section because we're looking across the surface anyway. But here to get this depth, it's important to put it as cross section. So I'm going to place it here. As you can see, we have about we want those yellow lines to sort of align, and we have about 2.347 at the bottom and 2.132 at the top for a length of 4.947. So here the calculation is going to be with a calculator. Is it working? Yes. All right, and what we want to do here is actually I'm going to go grab my notes. Okay, so here what we're going to do is we're going to take the larger diameter, divided, subtract the smaller diameter. So we get 0.215. That 0.255 gets divided by the length, by the height of the pillar that we have here. 7. And we divide that by 2 because we're considering the angle on one side, right? To have the taper. We just want a taper on one side. So we divide it by 2 once again. And here we have 0.0217. And this is going to be the inverse of the tangent of the angle we want. So then we just do, this inverse tangent. Sorry, it is a tangent of the angle that we want. So we just do inverse tangent on that answer. And here that gives us, so this one, for example, has a taper angle of about 1.24, which is good. This is below 1.5. This is what we want. Ideally, I like to have something that's under 1 micron, under 1 degree. So let's try to just thin it one more time and see if that helps. But if not, we're going to keep that and it's perfectly fine as well. And here I add quite a lot of Z because I want to stay at the surface slightly longer. So that's going to take 40 seconds. Okay, we'll see if that has had an impact or not. Okay, but again, it's already looking very good. So I'm not bothered if it's not working. And as you can see, I'm not taking the length quite all the way at the top because, like I said, it's this taper. I'm taking it slightly below, and that's completely fine. But here, I'm also seeing that my action seems to be currently making that top taper a bit more pronounced, maybe more than I would like to. And here, well, here the length is clearly about the same, and we have about the same bottom and top. So it seems like it's about as good as we're gonna get it here. But again, we are well within the sort of values we'd expect. And of course, if I take it like all the way down there, and place it here and change the length accordingly, that's going to give me a different value, right? But if you've done your job right, your final tapering angle should not be that different. So I'm going to do the same calculation as before. Yeah, because this is a remote connection, moving these takes a hot second. Right, so measuring it here, that gives us actually a taper angle of 1.12. So we're still in the same area. All in all, I'm very happy with this. I'm just going to take a picture of it. I like to finish every time with a picture. And you can see that the size, so I have not made the total length, but if I were to grab the total length and knowing that it goes, a bit deep in there, we definitely around that 6 micron size that we want. Okay, so I'm simply gonna, at this point, take a nice picture. Whoops. Sort of move these guys around. Don't need better quality than this. I mean, for my purposes, at least it's not needed. There you go. So F2 for the picture. And that's just going to be saved. here to save my images, I like to give them, you know, a name that makes sense. So here, I would simply go that. So I'm doing I'm working on an alloy called a Senkov, and this is my very first pillar, so I'm just going to call it 1. And I put the date there. Okay, ooh, there's a bit of charging, that's okay. All right, we can remove these. And with that, we jump to the next one. So as you can see, this stage takes a bit longer. It's closer to maybe, you know, 15 minutes on that one. These ones are going to go faster, of course, because I'm sort of done faffing about and trying to find the right combination. But it still takes a bit more time for sure. So we were at 4, and we established that 1. We really needed 1 micron to get this entire thing. And you see, this one is a bit more spread out, so I'll put it at 4.3 maybe. Yeah, there you go. 4.2 might be enough. You know, I also want to spend, you know, I don't want to spend any extraneous time, so the smaller the circle, the shorter the I-beam. Okay, and we're gonna launch it. Okay, so like the first pillar, we still have some taper, but it's been greatly reduced. So now we can sort of use a smaller, maybe about 3 microns. Yeah, 3 microns will do. So smaller quantity here. And I'll put it as as 1 micron as well, because I want to, as I was trying 0.5 earlier and it was clearly not maybe aggressive enough. So here we want to kind of make it really work. Okay. And I want trying to center around the dark circle. All right, here we go. Okay, this is looking good. What do we have here? Right, we've had a slight drift, but this is already looking quite good. Let's have a look at the sizes. Here, 1.2.2, a bit less maybe. 2.15, and here about 2.46 over 4.5. So that gives me an idea. I don't think it's quite there yet, but at least I know. Right, so that's not obvious, but like this is about an angle of 2 degrees here, which is a bit more than what we'd like. So we're back to the workshop. Okay. I think here we can, do we have a 2.4? Yeah, it's contained by 2.4, so I quite like that. I'll put it as 1.5, and I think we'll be good to go with this. All right, let's have a look now. This is looking quite good. Okay, 4.6. Okay, that's just a bit above 1 degree. This is 1.09, so we completely fine. I'm happy with that. I'm just going to take a picture. Playing a bit with the focus. And here we go. Okay, and from there, no particular surprises. We're going to continue doing the same thing. We're going to continue doing the same thing with the other ones. I'm just going to remove these up. Lovely. So see, I sort of like gave it a bit of a try on the first one to sort of establish what's going on. And now I know roughly what my recipe is. And my recipe is the first is at about 4 microns for 1 micron depth. The second one is 3 microns outer diameter, 1 micron depth. And then there's maybe 1 or 2 passes with either at 2.6 or 2.4. So yeah, a small pass at 2.6 and a longer pass at 2.4, and it seems to be doing the trick. Once you've done it once or twice and it seems to give you the same results over and over again, fairly confident that it's going to continue this way. Okay, for the rest of this tutorial, I'm not going to give a lot of commentary because this is exactly the same thing. But the last thing I would say is that, as you can see, it's a bit of tinkering. No two materials are ever going to be exactly the same. Um, there's always a bit of shifting a bit things around to make sure that they fit as intended. And that's just something that comes with scenery. It's just something that you have to get used to as you do these. It is a science, but slightly an art as well. But yeah, I'm just going to continue on what I'm doing right now, and I'll have 4 pillars in about uh, 15 minutes, I think, if I'm doing things well. All right, that's all, folks. So at this point, I'm going to wrap up this recording. The only thing I've got left to do is sort of go back to the no tilt position. So we are at 52 degrees, of course. And I'm going to bring it back down. And from there, yeah, just going to bring it back to its neutral position. And I'm just going to vent. So I'll stop the recording now.